Section 14.7 Reactions of acids and bases. Typical reactions of acids and bases include the reactions of acids and metals, bases and carbonate and bicarbonate ions. For example, when you drop an antacid tablet in water, the bicarbonate ion and the citric acid in the tablet react to produce carbon dioxide bubbles, water, and salt. A salt is an ionic compound that doesn't have protons or as the cation or hydroxide as the anion. Acids and metals. Acids react with a certain metal to produce hydrogen gas and a salt. Active metals include potassium, sodium, calcium, magnesium, aluminum, zinc, iron, and tin. In these single replacement reactions, the metal ion replaces the hydrogen in the acid. Acids react with carbonates and bicarbonates. When an acid is added to a carbonate or a bicarbonate, the products are carbon dioxide gas, water, and a salt. The acid reacts with the carbonate or the bicarbonate to produce carbonic acid, H2CO3, which breaks down rapidly to carbonate or carbon dioxide and water. Acids and hydroxides. Neutralization. Neutralization is a reaction between a strong or weak acid with a strong base to produce salt and water. The hydroxide of an acid and the proton of an acid and the hydroxide of a base combine to form water. The salt is the combination of the cation from the base and the anion from the acid. We write the following equation for the neutralization reaction between hydrochloric acid and sodium hydroxide. If we write the strong acid HCl and the strong base NaOH as ions, we see that the proton combines with hydroxide to form water, leaving the ions sodium and chloride in solution. When we omit the ions that do not change during the reaction, which are spectators, we obtain the net ionic equation, and the net ionic equation for the neutralization of protons and hydroxide to form water. Balancing neutralization equations. In a neutralization reaction, one proton always reacts with one hydroxide. Therefore, a neutralization equation may need coefficients to balance the proton from the acid with the hydroxide from the base, as shown in sample problem 1410.